Hello, welcome to another problem session. Today we have a problem from Indian JEE, and in this problem we are going to work on angular momentum problem. So this is angular momentum problem, and let's look at some of the things that are given. So we have a two disks of different masses and different sizes, actually one twice as large as another, and they're separated by a thin massless rod L, and this L is given. This L is given to be that's important actually, and there are various questions. It rotates, and then there's a rotation here because the whole thing is rolling around, and there's a question about how relation of this with that. This is given, and then we have to find that in A. In B, we have to find angular momentum of the center of mass. So if I put all of these masses, so if I put all the 5 m's over here, what will be, this is the center of mass, what will be angular momentum of that, and then magnitude angular momentum of the assembly about its center of mass. So it's about this axis. So C is about this axis for C, and the D is net angular momentum. So this one is that direction, and center of mass is in that direction. So this is LCM, and this is L, let's say spin. So net is this plus this, so L is LCM vector plus LS vector, and D is about the Z component of that. So we have to get the Z component of that. So that's the D. Because now that we have the problem, it's going to take a while to go through each one of the problem sections in explanation, but in the exam time you don't have that much time. But if you understand the principles, you can really speed up your calculation. So let's see, let's do A. Because we have any of them can be right or wrong. So these are actually 4 problems, actually four problems here. So we have to check if it's true or false. We can't just guess it. So if you look at A, we want to know how the center of mass, so this is omega, so we want to know omega. So the center of mass is, so do I need to know where the center of mass is for A? Not really, because the entire structure will be going. And so if we just look at this motion, this will return. So this small disk will be rolling, just rolling of a small disk is enough around Z axis is same time as movement of CM around Z axis. So this is the main point here. So when we look at this, so if I'm going to go figure out this radius, say radius 1 for disk 1, this radius, you can see the radius, we really don't, the amount the radius can be L and A, and you can figure out from there. So if you look at this, so the second thing to notice is this angle here is 90 degrees. Okay, so this is L, which is, that's why square root of 24a, and a is given. This is weird looking given because I can figure out this R1 nicely. So R1 is going to be a is square root of 24 plus 1, the squares of this plus squares of that, and a square root, that gives me 5a. So how many times this will go in one full thing? So omega, so delta t takes delta t to go full around. So if it's omega, if it's delta t to go around, then it's going to be 2 pi. It's going to be 2 pi in delta t. That will be omega. That's so that will be delta t is 2 pi over omega, right? So this is one thing I can observe going around. And from the rolling, you can say that if I'm going to make so many turns, so in delta t, number of turns, n will be 2 pi a times n. It will be same distance as 2 pi r1. So 2 pi's all cancel out. So number of turns is r1 over a. Okay. So that's one observation you can make it. Another observation you can make it is from the rolling is it's going to go 2 pi r distance. It's going to be 2 pi n angle in delta t. So this n turns, so it's going to make this many angle in delta t, and it's going at little omega, So omega delta t is 2 pi n. That means delta t is 2 pi n over omega. So this is delta t, and so turns out this one n can be right over here, 2 pi, and r1 over a is actually 5 turns. So I'm going to make 5 turns over omega, so delta t. So I just put it over here. So I'm going to get 2 pi times 5 over omega is 2 pi over big omega, and you can see that everything cancels out. Omega is indeed 1/5 as much. So this is a complete calculation that tells me A is okay, is correct. Okay, let me erase this and look at B now. Okay, so B is about angular momentum, this L, right, is about this part of the center of mass, and it says claims is the answer. Let's see if that's correct. Okay, so the B, so we need to formula wise, if it's going in a circle of radius, say capital R, then this moment of inertia, so ICM, this is about Z, is going to be the entire mass placed over here, the CM, times capital R square, right? So that's going to be 5m R square. We don't know R yet. So that will mean L Cm z component is 5m r square, and it's going with capital omega at this rotation, so is capital omega, and capital omega is 5 of this is equal to 1 mr square omega. That's from here. This one we had solved omega equals to omega over 5, or 5 omega is omega. That's excuse me. So here we need to figure out what the R will be. So what's that R? We can find the center of mass location. So if you look in this direction, this is distance L, and this is mass M and 4m. So say this is where the center of mass is. So if this is B, and so we can just take this sum x equal to 0, then this will be x equal to L in temporary axis here, just for this calculation, because center of mass will be along this direction. So I'll have a B equals to the total mass 5m, m times 0 plus 4m times L. So this is 4/5 L. Okay. So we want this distance. That's the R. We want that distance. So this one is L plus B. So L plus B, this side, we want that. And if we had a height, I would be all done, right? And actually we can get the height, because you can see that this is so hard to get this height. If this was height of the CM, it would be very easy to get the answer. So over here we have A, and this distance was 5a. So this angle theta, will be sine of theta will be a over 5a, so 1 over 5. So this theta, and this one is L plus B, then H will be L plus B times sine theta. So B is 4/5 L, so L plus 4/5 L. Sine theta is 1 over 5. So this whole thing is 9 over 25 L. So the R will be simply H square plus L plus B square. H square plus L plus B square square. So if let's see what the H square is. H square is 9 over 25 square L square. This one is 9 over 5 L square. And L is as given square root of 24a. So you can say 9 square over 25 square L square plus 9 square over 5 square L square. So you have a 9 square over 25, 1 over 25, 1 over 25 plus 1, and L square is 24 a square. So we have from all of this, you can see, can I get 81 over ma square? Clearly I would not be able to get it. Okay, so let me write the whole thing. So we have LCM is equal to this 81 over 25 square, and this is 20 times 24 times 26. This factor times m times a square omega, and this is not equals to 81. So this is incorrect. B is incorrect. But we got an expression for this, which might be able to use it for the z component over here. Okay, so let me write that down. This should have been 81. Instead of 81 should be 81 times 24 times 26 over 25 times 25 m a square omega. Now we'll do C. Okay, actually C is pretty easy problem to do because it's about the spin motion. And so we have moment of inertia from here and moment of inertia from here about this axis times the rotation, right? So I about axis, let's call it axis, just axis. I axis that's equal to the disk. These are disks. Make sure that they're disks, circular disks. So that about this axis is going to have m a square for the little disk plus half 4m 2a square for the large disk. So let's see, this one will need further expansion. So this is going to be 2, and that's going to be 4 and 4 is 8 m a square, and so 8 and a half, 8 plus a half m a square. Okay, so this is 17 over 2 m a square. Okay, so L axis magnitude, the direction is actually in that direction. That's the direction using right hand rule. You do right hand rule and it's going to point in that direction. So I axis magnitude, just I axis and omega axis, and that's omega, just omega. So 17 over 2 m a square omega, and sure enough, this is correct. This is correct. Okay, now we'll do D. Okay, D is C was very easy, right? Now D is probably not going to work out right, because we had a B had a problem, and the D is kind of made up of those two things. So L is LCM plus L axis vectors. So L of Z is LCM vector z plus L-axis vector z. So this one is already, we have that. So so if you look at it is in k-hat direction. So this one was plus 81, 24, 26, 25, 25 m square omega, and this one was pointed in that actually in that direction. This is the z-axis. L-axis vector is pointing in that direction, and this is theta. Sine theta equals 1/5. That's the answer we had earlier. So this is the theta. So this will, we want, that's the component LZ. This is the z component we project over here. So this is going to be negative, and so this is going to be negative L-axis sine theta. So L-axis was 17/2. So this is equal to minus 17/2 m a square omega, and this is 1/5. Sine theta is 1/5. So I have to see if 81 times 24 26/25 times 25 minus 17/2 times 5, is this equal to 55? That's what you have to check. Just from the look of it, looks like not going to be the case, but actually if you go detailed calculation, answer is no. So this is not. So those are the detailed explanations of each of the problem. I wish this had worked out, this particular one, or even B, they had given the correct answer, so that you could see how vectors can be added. But that's the way vector addition would work out. Okay. All right. So this is enough for today. I will talk to you in another video. Bye.